Welcome to a webcast produced by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Numeracy series and concerns rules for dividing whole numbers. This guide illustrates some rules concerning the division of whole numbers. It gives a starting point to help you develop division strategies, for example, long division and cancelling down. These rules only concern whole numbers. Introduction. There are 4 basic skills in numeracy: adding, subtracting, multiplying and dividing. If you are comfortable with each of these, your confidence will improve and your level of numeracy will increase. Out of the 4, dividing is thought of as the most difficult. You may remember long division from school. However, being able to divide 2 numbers is a crucial skill, and many divisions can be performed without long division. Also, a good understanding of division helps to give a good understanding of fractions. This study guide gives useful strategies to help you decide whether or not a number can be divided by another number to give a whole number. In mathematics, the word divisible is used to describe whether a number can be divided by another number to give a whole number result. For example, 10 is divisible by 2, giving 5, but not by 3, which has remainder 1. Numbers divisible by 2. A number is divisible by 2 if the final digit of the number itself is divisible by 2. This means that all numbers ending in either 2, 4, 6, 8 or 0 are divisible by 2. In other words, all the even numbers are divisible by 2. Numbers divisible by 3. A number is divisible by 3 if the sum of all the digits in the number is divisible by 3. Example: is the number 3627 divisible by 3? Adding the digits of 3627 gives 3 plus 6 plus 2 plus 7 equals 18. As 18 is divisible by 3, 3627 is also divisible by 3. 3627 divided by 3 equals 1209. Cool. Numbers divisible by 4. A number is divisible by 4 if the number formed by the last 2 individual digits of the number is divisible by 4. Example: is the number 3628 divisible by 4? The last 2 digits of 3628 are 28. 28 is divisible by 4, so the number 3628 is divisible by 4. 3628 divided by 4 equals 907. Numbers divisible by 5. A number is divisible by 5 if the last digit of the number is 0 or 5. Numbers divisible by 6. A number is divisible by 6 if it is divisible by both 2 and 3. You can use the rules above to determine if a number is divisible by 2 or 3. Example: is the number 31,254 divisible by 6? As 31,254 is an even number, it is divisible by 2. Adding the digits 3 plus 1 plus 2 plus 5 plus 4 equals 15. 15 is divisible by 3, so 31,254 is divisible by 3. As 31,254 is divisible by both 2 and 3, it is divisible by 6. 31,254 divided by 6 equals 5,209. Example: is 9,518 divisible by 6? 9,518 is an even number, so it is divisible by 2. 9 plus 5 plus 1 plus 8 equals 23, which is not divisible by 3. So 9,518 is not divisible by 3 and therefore cannot be divided by 6. 9,518 divided by 6 equals 1,586, remainder 2. Numbers divisible by 7. To determine if a number is divisible by 7, take the last digit off the number, double that digit, and subtract it from the remaining number. If the result is divisible by 7, then the number is divisible by 7. If you are looking at a long number, this process may need to be repeated several times. Example: is 3,101 divisible by 7? Firstly, remove the last digit of the number, which was 1. This gives 310. Next, double the removed digit and subtract it from 310. The removed digit was 1, which we then doubled to get 2, and then subtracted from 310 to give 308. If you still don't know if this is divisible by 7, repeat the process by taking off the 8. This leaves 30. Next, we double the removed digit 8 and subtract it. Doubling the removed digit 8 gives us 16, so we take away 16. 14. So the result is 14, which is a multiple of 7. So 3,101 is divisible by 7. 3,101 divided by 7 equals 443. Numbers divisible by 8. A number is divisible by 8 if the number formed by the last 3 individual digits is divisible by 8. This requires a good knowledge of your 8 times table. However, here is a shortcut. If the result of dividing the number by 2 twice is an even number, then the original number is divisible by 8. So you can apply this rule to your last 3 digits. Example: is the number 8,624 divisible by 8? You need to determine if the last 3 digits of 8,624 are divisible by 8. Using the second technique, divide the last 3 digits by 2. 624 divided by 2 equals 312. Now divide this result by 2. 312 divided by 2 equals 156. As 156 is an even number, it follows that 624 is divisible by 8, and so is 8,624. 8,624 divided by 8 equals 1,078. Numbers divisible by 9. A number is divisible by 9 if the sum of all its individual digits is divisible by 9. If the result of addition is a large number and you're not sure if it's divisible by 9, the process can be repeated on this result. Example: is the number 4,653 divisible by 9? Add the digits of 4,653 to give 4 plus 6 plus 5 plus 3 equals 18. As 18 is divisible by 9, so is 4,653. 4,653 divided by 9 equals 517. Numbers divisible by 10. A number is divisible by 10 only if the last digit of the number is 0. Numbers divisible by 11. A number is divisible by 11 if the alternating sum of its digits is either 0 or divisible by 11. To find the alternating sum, you write the first digit of the number, subtract the second digit, add the third digit, subtract the fourth digit, and so on. Be careful, as this method may involve negative numbers. Example: is 1,364 divisible by 11? The alternating sum for 1,364 is 1 minus 3 plus 6 minus 4, which equals 0, which tells you that 1364 is divisible by 11. 1364 divided by 11 equals 124. Further guidance and information. If you have any further questions about numeracy or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a Learning Enhancement tutor in the Dean of Students office. You can telephone 01603 592 761 or email dos.help@uea.ac.uk or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.